Good morning and welcome to our pre-calculus class for 40S. Um, Today, actually, what we're going to do is we're going to get started our chapter 7 booklet, and we are just going to go over lesson 1, examples 1 through 4, focusing on solving first degree trig equations. So a lot of the stuff that we talked about um, in chapter 6 in terms of the trig unit circle stuff, um, all of our um, all of our angles, terminal arms, um, they're all going to be part of this one. Okay, so thank you for tuning in today. So in terms of this one, yeah, like I said, we're going to do the first degree trig equations. We already have explored solving trig equations in both degrees and radians. We kind of did that already. So in this lesson, we will expand on the concepts that we learned in chapter 6. So in terms of chapter 6, we talked about solving equations. So let's take a look at this one here, example number 1. Cos of theta is equals to negative 1/2 over the domain from 0 to 360 degrees. So in this particular case, we were looking for an angle, we're looking for theta, where the cos of theta is equals to negative 1/2. So how do we figure this out? Cos of what angle will give us a negative 1/2? First, let's ask ourselves, where is cos negative? Where is cosine of the angle negative? Okay, so when we looked at that one, we wrote this down, cast, C-A-S-T. This means in quadrant 1, all of the trig functions are positive, or trig values are positive. And then in quadrant 2, only the sine is positive in quadrant 2. Only the tangent is positive in quadrant 3. And then in quadrant 4, only the cosine is positive in quadrant 4. So in this particular case, where is cosine negative? So it's going to be cosine is negative in quadrant 2 and quadrant 3. So in quadrants 2 and quadrant 3. Okay, so we know that there could be possibly many solutions in this particular domain from 0 to 360 degrees. Okay, so in that particular case, where can we go? Remember our unit circle is this. Cos is negative 1/2. So this is negative 1/2. So what angle is that? And this is also negative 1/2 down here. Okay, I should put a dot there. So we have two possibilities, one going this way, that's one, and then the other one is going all the way here to there. So two solutions, two angles. So what does that mean? Well, where is cosine neg? The reference angle here is 60 degrees. Okay, so cos, when we look at this one here, cos, a reference angle would be cosine of just a half. So if we were to look at the reference angle on the angle here in quadrant 1, our reference angle would be 60 degrees. 60 degrees. So solution for quadrant 2. So therefore theta in quadrant, I'm mixing up my theta and quadrant. So quadrant 2 is going to be theta is equals to 180 minus 60. So that's going to give us 120 degrees. And theta in quadrant 3 would be 180 plus the reference angle 60 degrees, which is 180. So it's going to be 240 degrees. Okay, so we have two possible solutions. Oops. Now, how do we know if our answer is correct? Just like in any solutions that we have, just like in any solution for an equation, we can check our answer. Okay, so I'll just try to squeeze it in here. Okay, so we can check our solution. Okay, so here's what we're going to check. We're going to check both solutions in here. Okay, so so if you go cosine of 120 degrees, okay, and remember, because our domain here is in degrees, so we want to make sure our solution is in degrees as well. So let's type that in. Okay, let's type it in. Cosine of 120 is going to equal to negative 0.5, negative a half. So the left side of the equation is a negative a half or negative 1/2. And then the right side of the equation is negative a half. So that means our answer is correct. Okay, so that's for this solution. Now what we're going to do is we're going to check this one here. Cosine of 240 degrees, is that going to give us a negative 1/2? Is that going to give us negative 1/2? So let's go ahead and type that in. Cosine, okay, make sure it's in degrees on a calculator. Cosine of 240 degrees. Yeah, we got a negative 0.5, which is a half. Negative a half is equals to the negative 1/2. The left side is equal to the right side, which is correct. Okay, so just to kind of review this part in here, we got to take a look at, well, cosine of theta is equals to a negative 1/2. We kind of figure out where is cosine negative. We figured out it's going to be in quadrants 2 and 3. That shows us there could be a few solutions in here. So in this particular case, I drew the unit circle, so kind of has a visual. So this is our visual. Okay, so where is cosine negative a half? Negative a half is here. So that means the reference angle, okay, so if we do the reference angle, maybe I should have elaborated on that a little bit clearer. Okay. I'm going to back up a bit here. So how can we figure out the theta r, the reference? So I can go here, cos inverse of 1/2. So theta r, okay. So theta r 0.5 is 60 degrees. Okay, so you could do that, or if you already know that on our unit circle, that's perfect. Okay, so that's that example number one. So let's see, what else do we have in here? When solving a first degree equation, trig equation to be specific, isolate the trig function so that the equation is in the form sine of a equals to number, or cos of a equals a number, or tan of a where a is a constant, and then give exact solutions wherever it's possible. So in this particular case, we're going to do that. Determine the exact roots solution for trigonometric equation. So this is the one that we're looking for. This is the equation. So 2 square root of 2 sine of x minus 3 equals to -2. Okay, so we can't just jump right into our unit circle and see if what will give this, what angle is this that will, if we do all these things, we're going to get a -2. So what we're going to do is we're going to try to isolate x, or at least isolate the sine of x. So how do we do that? We're going to take this to the other side of the equation. So it's going to be square root of 2 sine of x equals, and I got -2, but then if I move this to the other side of the equation, it's going to give us a +3. So in that case, we're going to get -2 plus 3. Simplify that. So sine of x equals to 1. And then divide both sides of the equation by square root of 2. So divide by square root of 2. So to get sine of x equals to 1 over root of 2. So where is sine of x equals to 1 over root of 2? When we did our trig equation, or sorry, unit circle, we probably don't recognize this one here. We could also write it this way. The rationalized denominator. Okay, to rationalize a denominator is probably something that's we are more familiar with, like the root 2 over 2. So to do that, I'm gonna multiply root 2 over root of 2. Of course, this is something that you've learned in grade 11. So sine of x equals to 1 times root of 2 is root of 2. And a square root of 2 times square root of 2, that's going to give us square root of 4, which is 2. Okay, so sine of x is equals to root 2 over 2. Now let's take a look. Where is sine positive? Okay, I'm going to go back up here. We're going to ask ourselves, where is sine of x positive? Okay, where is sine of x positive? Well, it's positive in quadrants 1 and 2. So it's positive in quadrant 1 and quadrant 2. Okay, now we're going to recognize that this number is one of the special angles that gives us a square root of 2 over 2 as a sine of x. Okay, so let's see. Now, if you don't recognize that this is a special angle, okay, special angle, you could go sine of x. Okay, so what we could do is we can go sine of x equals to root 2 over 2, and then to figure out the x, you're going to take the sine inverse of root 2 over 2. That's going to give us x is equals to 45 degrees. 45 degrees. So if you go here, sine inverse, okay, my domain is in degree, so I have to make sure that my calculator, it says degree mode. And then I'm going to go root 2 divided by 2. It's going to give us 45 degrees. So that's our reference angle, and that's also the angle in first quadrant. So that's our angle in first quadrant, 45 degrees. And 45 degrees there. Okay, make it look like 45 degrees. There you go. There. So this is 45 degrees, a reference angle. Maybe I should put the reference angle there. And then 45 degrees there. So this, therefore, x in quadrant 2, start with quadrant 1. Quadrant 1, it's going to be theta is equals to 45 degrees, because the reference angle and the angle in standard position is equal to each other, are equal to each other. Now, what about the x in quadrant? Why do I keep putting theta? Quadrant 2. Quadrant 2. In quadrant 2, it's going to be theta is equals to 180 minus 45 degrees. 180 minus 45, it's going to be 135 degrees. Okay, so 45 degrees and 135 degrees. Now we're going to take a look. Is our answer correct? Okay, so we have to check if our answer is correct. So I could do that. I'm just going to do that on my calculator. So in wherever I found x, okay, I should put x here because it's not theta. So x. Wherever I find x, I'm going to substitute 45 there and then try it to see if I'm going to get the left side equaling to the right side, which is -2. And then I'm going to try 135 degrees and to see if that's going to, the left side will balance or equal to the right side. So let's do that. Okay, so I take my calculator. I'll just do everything on my calculator. So square root of 2 times sine of 45 degrees. Okay, sine 45, that's where I am. And then minus 3, -2. So that gives us a -2 when I substituted that onto x, and it's correct. Left side is equals to the right side. Now let's go ahead and calculate this one. Okay, like substitute 135 for x, and to see if the left side of the equation will equal to the right side of the equation, which is a -2. So let's go ahead and try that one. So square root of 2 times sine of 135. Okay, now some calculators, when you press sine, it automatically opens up a bracket. So type in your 135, but make sure you close it. Okay, so that just came into my mind just now. So sine 135 and then -3, and that's going to give me -2. So that means these two solutions that I got are correct. Okay, and I checked it. So that's great. So we're done. Example 1 and, well, halfway of example 2. So I'm not celebrating it. Okay. So solve the equation 5 tan theta plus root of 3 equals 2 tan theta. And now here, what are we seeing in here? We're looking at the angle in radians. Okay, but the radian angle is from -2 pi to +0. So that means, remember, the negative angle means that it's rotating to the clockwise direction. Okay, so let's keep that in mind as well. So what we're going to do is we're going to try to isolate theta in here and find out the angle within this domain. Okay, so let's do that right now. I'm going to try to move it over here. So 5 tan theta plus root of 3 equals to 2 tan theta. Okay, so I see that tan theta is on the left side of the equation, and then I also see a tan of theta on the right side of the equation. So what we're going to do is we're going to put all the one that has a tan theta on one side and all of the just the numbers on the other side. So I'm bringing all of these over there and then the root of 3 on this side. Yeah, so like that. Now, what are we going to do? You got 5 tan theta minus 2 tan theta. We can just say, hey, that's going to be 3 tan theta. Okay, so 3, what are we going to do? Well, we got to divide both sides by 3. So tan theta is equals to negative root of 3 over 3. Now, this is going to be really, really interesting because this is a rationalized denominator. Okay, rationalized denominator. So what we're going to do is, because we want the exact value, what angle will where the tan of theta is negative? So where is tan negative? Where is tan of theta negative value? Okay, so tan is negative on quadrants 2 and quadrant 4. So in quadrant 2 and quadrant 4. Okay, so those are the two possible solution. Now, this one in here, let me pull out my unit circle. So let me find it first. Because it's been a while that I find my unit circle here. Okay, here we go. Just gonna show it. So this is our unit circle from page 24 in chapter 6, part 1. So it says here, all of these values, this is cos of the theta, sine of the theta. None of these are tangent. So how can we figure out the tangent? Tangent is sine divided by cos. Now, if we do for every single one in here, okay, for every single one there, where is tan going to be negative root 3 over 3? So let's take a look. We could figure out the tan of a reference angle. Tan of a reference angle. Now, because we're just doing the reference angle, we're just going to take the positive value of that, root 3 over 3. That will make our life so much easier because that will give us a reference angle. Okay. Now, because this is rationalized denominator, this is going to be rationalized denominator. Theta r, okay, so theta r, get a paper. I'll just show it to you right here. If we take tan of pi by 6, it's really going to be sine of pi by 6 over cosine of pi by 6. And then when we look at, well, what's sine of pi by 6? That's going to give me 1/2. And then what's a cosine of pi by 6? That's going to be √3 over 2. So if we divide that, the denominator cancel each other out, we're going to get 1 over √3. Normally, this is what we see. But if we rationalize the denominator in this particular case, that means we're going to multiply by √3 over 3. So we're really multiplying by 1. So we're not changing the value. 1 times √3 is √3. √3 times √3, that's going to give us √9, which is 3. So this is what we see on our equation. Okay, so this has been a value where the denominator has been rationalized. So that means theta r, the reference angle, is pi by 6. So pi by 6, reference angle. Okay, so here's a visual. Okay, we always want to have a visual here. Okay, we know that the angles are in quadrants 3 and 4. So it's going to be 3, and quadrant 4. Okay, but in this case, the reference angle is pi by 6. Pi by 6, so this is going to be pi by 6. And then this angle is pi by 6. Okay, so what is the angle in standard position? I got to remember that the domain is from -2 pi to 0. So we're rotating clockwise this way. So in quadrant 4, okay, so that's this one here, theta is equals to 2 pi minus pi by 6, okay, because we're rotating this way, and that's our angle, negative. So what would that be? So if I multiply this by 6, that's going to give us 12 pi over 6 minus pi by 6. So that's equal to should go like this. -2 pi plus pi by 6. So it's going to be -11. Let's see here. Actually, don't need to do that because I can see it. Make my life easy. Okay, make our lives easy. I know I gotta go this way, so it's gonna be negative pi by 6. I don't have to do all that extra calculation. I know it's gonna be negative pi by 6. Okay, so now in quadrant 2 rather. So 1, 2, 3. So in quadrant 3, why do I say quadrant 3? Quadrant 2. In quadrant 2, oh, I know why I see it. This one should be 2. In quadrant 2, it's going to be negative pi plus that another turning up this way, pi by 6. So theta is equals to negative pi, and then turning more pi by 6 that way. So that's going to give us negative 7 pi by 6. Negative 7 pi by 6. Okay. This negative is really messing up with me here. So let's kind of take a look. Let's review here. We tried to solve for tan theta. So we did our algebraic manipulation here. So that tan theta is negative root 3 over 3. And then we recognize that this is going to be, this is a rational version of negative 1 over root of 3. And then we said, oh, where is tangent negative? So tan is negative in quadrants 2 and quadrant 4. So it should be 2 and 4. So from there, we figured out the reference angle. So reference angle is pi by 6. So we know that this is going to be pi by 6 and this is going to be pi by 6. So we looked at quadrant 4. What's the angle in quadrant 4? Remember, we're turning this way because it's a negative angle. So it's going to be negative pi by 6. And then if we go from here to quadrant 2 this way, it's going to be negative. From here to here is negative pi, and then another negative turn, pi by 6 more. So to get a negative 7 pi by 6 radian. So what we're going to do, these are our two possible solutions. So what we can do is we can check. Okay, so we can check our solution. Okay, so I need my calculator. I'm just going to do that right here. So it's going to be 5 times 10. Okay. Oh, I can see I have to change my calculator into radian mode because this is in radian. So I'm going to do that before I do anything else. Okay. So I'm going to substitute theta with negative pi by 6. So I'm going to go negative pi by 6. Okay, I'm using my brackets because I want to take the tan of all of these. Okay, so 5 times tan of negative pi by 6 plus 3 plus square root of 3. And I get negative 1.154. Okay, so on my left side, I'm going to get a negative 1.154. Okay, so I got to remember that. Negative 1.1547. Okay, what's on my right side? It's 2 times tan of theta. So I'm going to do the same thing in here. Tan of theta, I'm going to replace it with negative pi by 6. So it's going to be 2 times tan of negative pi by 6. And I get the same thing. Okay, I got the same value. So the left side is equal to the right side. I'll write that down in here. So this is our checking. So I go 5 tan of negative pi by 6 plus root of 3 is equals to 2 tan negative pi by 6. Okay, and I calculated this, and this is what I got. And then I calculated this one, and this is what I got as well. So negative 1.1547. So they're the same thing. So that means our equation is correct. Okay. Okay, sorry you can't see that. There you go. Now I'm going to check the other one. 5, 10. Okay, I'm going to check negative 7 pi by 6. Negative 7 pi by 6 plus root of 3. And then whatever that is, it should equal to 2 times tan of negative 7 pi by 6. Okay, so let's see this. And we can write down our solution. And then we're going to see this one side. And let's see what kind of solution we get. To see if our answer is correct, the left side should equal to the right side. So let's do that. Let's see. 5 times tangent of negative 7 pi by 6, negative 7 pi divided by 6. And I have to do the brackets this time, okay? Because I have to take the tangent of all of these information. Plus root of 3. Okay, and I'm going to get a number. I got a negative 1.1547. And then let's go to the other side. Let's see if that's going to be the same thing. 2 times 10 of negative 7 pi by 6. Okay, and that's it. And then equals, it's going to be negative 1.1547. It's the same thing. So that means our solutions are correct. So these two are the solutions, and those solutions are within the domain that's given. Okay, so that's great. Doing all of these stuff is actually everything that you know about math, like solving equations, our trig stuff, the cast method, reference angle, everything that we've learned before are just coming into this one example. Okay, let's see. We're on example number 3. Example number 3. What does that say? Let's read it first. Like I said, we're going to be going only up to example 4. So example 3, determining approximate roots of trigonometric equation. So when they say in the example, in example 2, they want the exact, it actually will tell us, because it's an exact, it has to be one of those special angles. Okay? But because this one in example number 3, determining the approximate roots, when we say approximate roots, most likely it's going to be not one of those special angles. Okay, so when they say approximate, it means the solution, okay, the angle is not the special angles. And we know what those special angles are, right? Special angles would be 0, 30, 60, 90, and basically multiples of those angles. The other angles that we are special angles in terms of radian would be 0, pi by 6, pi by 4, pi by 3, pi halves, and then multiples of those. But in this particular case, most likely not, because this is approximate roots. So let's take a look at this one and we'll see what that goes. Solve the equation of 5 secant x minus 4 equals 8 for the domain for x. Okay, we have to look for the x, okay, in between negative 180 degrees and 180 degrees. So now we're back to degree angle again. So our solutions have to be in degrees. So let's take a look. There's quite a bit of stuff that we gotta do here. First of all, let's take a look at this one. Well, 5 secant x minus 4 equals to 8. Secant is something that we would be easier to figure out if we change it into its reciprocal, which is a cosine. So I'll show it to you in a second. So 5 secant x, that's our angle, minus 4 equals to 8. So what I'm going to do is I'm going to bring this over there. Let's see. So 5 secant x equals to, I'll just skip a step. If I bring this over there, it's going to give us positive 4 plus 8 is going to give us 12. Okay, so that's easy. And then we're going to divide both sides by 5. So secant x equals to 12 over 5. Now, because secant and cosine are reciprocal of each other, so what I could do is cosine of x is equals to the reciprocal of this, which is 5 over 12. Okay, so now how did I know from here to here? Why? Why is that? Okay, so we know that the secant of x is equals to 12 over 5. Yes? So now if I want to express that as a cosine, secant is the same thing as 1 over cos, which is 12 over 5. Oh, cos of x. Okay, so how can we have the cos of x in the numerator? Okay, so if I cross multiply, that becomes 5 equals to 12 cos of x, and then divide both sides by 12, divide by 12, so cos of x equals to 5 over 12. Okay, and then it's just got the cos of x went here, and then the 5/12 goes there. So we know that I have to take the reciprocal of this, which is cosine. The reciprocal of secant is cosine. So I take the reciprocal of the left side, and then that means I got to take the reciprocal of the right side. So that's how I'm also thinking. So now that we have this part in here, you notice 5/12 is such a weird number. It's not one of those information that is in our unit circle. So now we got to ask ourselves, where is cosine x positive? Okay, and we know that cosine is positives in quadrant 1 and quadrant 4. Okay, so cosine is positive in quadrant 1 and quadrant 4. So what are we going to do? We're going to take the cosine of reference angle. Okay, I'm putting R there to indicate it's a reference angle, because once we figure out the reference angle, we can find the other um, coterminals. So cos of x, but this is reference angle, so it's going to take an angle in quadrant 1. So we'll see from there. It's 5/12. So to figure out the reference angle is equals to the cos inverse of 5/12. Okay, so gotta do that, and then it's gonna give me, remember, this is an approximate root, and it's not one of those special angles, so it's gonna be a weird angle here. Not weird, but okay. I gotta change my angle to degree. Okay, I have to always be aware of that one because this is degree. So cos inverse of 5 divided by 12, and I have to put that in brackets because so that I know that my calculator knows that I'm taking the cos inverse of 5/12, not just 5. And I get a reference angle of 65.38 degrees. So I'm going to take a look at the reference angle of 65.38 degrees. Let's have a visual. Let's see what that looks like. Okay, cosine is positive in quadrant 1 and quadrant 3. Okay, so the reference angle here is 65.38 degrees, and then this reference angle is 65.38 degrees. Great. So now what we're going to do is we're going to try to find the solution within this domain. Okay, so this is how I kind of think about it. I'm going to deal with what is the solution? What is the solution from negative 180 to 0? Okay, so I'll figure that out. That's going to be from negative 180 to 0. So that's figuring this part out. And then union, okay, you've seen this one before, union from 0 to 180 degrees. Okay, from 0 to 180 degrees. So that's from 0 to 180 degrees. So that will give me the solution right there. So therefore, solution in quadrant 1, I'll start with quadrant 1, theta, oops, it's not theta, they call it x. So x is equals to positive 65.38 degrees, because the reference angle and then the angle in standard position are equal to each other in quadrant. Now what about, okay, that's from 0 to 180. Now what about from negative 180 to 0? So that's going to touch on the negative angle. That's in quadrant 4. So x is equals to, it's rotating this way, so it's going to be negative 65.38 degrees. So we have two possible solutions in this particular case. So let's take a look. Now our calculators don't, I'm pretty sure your calculator also don't have it, but we don't have secant button at all. So what we're going to do is we can just go here. Cosine of x is 5/12. Okay, so I'm going to try to do that. Cosine of 65.38, okay, equals 0.4165. Okay, it's my checking. So the left side, checking. So cosine of 65.38, it has to be equal to 5/12. So I typed that in, cosine of 65.38, I got 0.4165 and a whole bunch of decimals. And if I type in equals 5 divided by 12, and it's going to be 40.416 repeating, which is pretty much are equal to each other. And the reason why it's not exactly like this is because we had to round it off to 65.38. Okay, now let's try to do the other one. Cosine of negative 65.38, that better be equal to 5/12. So let's see here. Cosine of negative 65.38. Okay, I'm going to get positive 0.416598. Okay. And then if I go 5 divided by 12, it's also about 0.416 as well. So they're equal to each other. So that means our solutions are correct. Okay, so that's great. How are we doing for time? Okay, well, we're going to go a little bit over time, but that's okay. Our class usually starts at 2 hours. Okay, so letter B. 5 minus 3 times tan of theta is equals to 2 tan theta plus 9. Okay, so you can see it's starting to get more complex, a little bit more complicated than as we go on. And that's how it should be. We can't be learning the easy stuff all the time. So here we go. I'm going to do that over here. 5 minus 3 tan theta, okay, equals 2 tan theta plus 9. Okay, so we have to find our angle theta, okay, within this domain so that when we substituted the values here and there, the left side is going to equal to the right side. So what's that? We're going to manipulate this equation so that we can solve for theta, tan theta, and then theta. So let's do that. So this 2 tan theta, I'm going to bring it over there, and then this 5 will be bringing over there. So what does that look like? Okay, and then we can simplify this. Negative 3 tan theta minus 2 tan theta. That's going to give us negative 5 tan theta. So negative 5 tan theta is equals to 4. And then from there, we can go tan theta is equals to 4 over negative 5. Okay, now we got to ask ourselves here, ask ourselves again, where is tan negative? Where is tan theta negative? Okay, so tan is negatives in quadrant 2 and quadrant 4. In quadrant 2 and quadrant 4. Okay, so what we're going to do first is figure out the reference angle, and then we can figure out where the angles are in quadrant 2 and quadrant 4. For now, calculate reference angle. Okay, so if we calculate the reference angle, and so that it's easier. I think this is easier for us to do instead of typing this in right away. Although you could type it in right away, it's going to give us an angle in quadrant 4, and then figuring out the reference angle from there. So I'm doing a little bit of a different strategy this time compared to what I showed you last time. So now let's calculate the reference angle. So we're going to pretend it's going to be in quadrant 1. So tan theta is equals to 4 over 5. I know this is going to be reference angle, so everything is positive there. So theta r is equals to tan inverse of 4 over 5. So slightly different approach compared to what I did last in chapter 6. Okay, so tan inverse, then, okay, now I gotta go back to radian mode. Oops. So tan inverse of 4/5. 4 divided by 5. I have to put the brackets there. It's going to be 0.6747 radians. I got to put the R there. This one, the uppercase R, means it's a reference angle, and then this little r means a radian angle, radian measure. So what are the solutions? Okay, we know that it's going to be in quadrants 10 is negative in quadrant 2 right there, and in quadrant 4 right there. Our reference angle is 0.67, so 0.6747 if we want to do everything, 0.6747. Okay, so we got to go back in here and see what does that say. Okay, we want to go from negative pi to positive 3 pi by halves. It's such a weird interval. Okay, so how do we do that? Such a weird interval. Because it's from negative pi to 3 pi, this is how I think about it. We have to negative pi, 3 pi by halves. Okay, so what I'm going to do is I'm going to focus on negative pi to 0. Okay, so from negative pi to 0, so that's going to give me, okay, if I actually outline that, that gives me this angle right here, but in a negative direction this way, right? And then union from 0 to 3 pi halves. So that means I'm going to go from 0 to 3 pi halves, which is up to here. So that's only this solution right there. So what's the solution? So in quadrant 2, it's going to be between this interval 0 to 3 pi halves. That's going to give me theta is equals to 180, which is pi minus 0.6747. 0.6747. Okay, it's going to give me a number. So pi minus 0.6747. It's 2.47 radians. Okay, and 2.47 radians is not one of our special angle. And then in quadrant 4, that's where from 0 to negative pi. So theta is going from 0 to negative pi. So that's really going to be just negative 67. Negative 0.67. Radians. So these two are the two solutions, the only two solutions there are within this domain. Okay. And if I won't do the checking on that one. I will let you do the checking if you want to do a checking on that one. Yeah, I'm trying to save a little bit of time. Okay, now we're on the last example for today. We're going to take a look at determining the general solution. When we talked about this trig function, it just keeps going repeatedly over and over and over and over again. So thinking about this one here, instead of limiting the domain, the solution be between this interval, we're going to be looking at all of the possible solution. There's going to be infinitely many because there are lots of coterminals for that particular angle. So that's what the general solution is. So instead of writing the one solution or two solution, we're going to write down the general solution. So determining the general solution of trigonometric equation. So let's see here. What does that look like? Solve the equation cotangent of x plus root of 3 equals 0. Now, spanning only from 0 to 2 pi, okay? And then once we see the pattern, we're going to write down the general solution, okay? So once we see the pattern in here, we're going to see, okay, I can see that there's going to be a lot of coterminals there, and then we're going to write down the general solution. How does that go? Let's try that one right now. So cotangent of x plus root of 3 equals to 0, like that. Now, again, we're going to isolate the x. We don't have a cotangent in our calculator, so what we need to do is we probably look for a different one that we could use instead of cotangent. And I'm pretty sure you know what I'm talking about there. So bring this over there. So cotangent of x equals to negative root of 3. Now cotangent of x. Okay, cotangent of x. The reciprocal of cotangent is going to be tangent of x. So tangent of x is equals to, so if I take the reciprocal of cotangent, I'm going to get a tangent. Now, if I take the reciprocal of this, I'm going to get a negative 1 over root of 3. And where is tangent negative 1 root of 3? Going back to my unit circle here. Tangent is sine divided by cosine. So if I take 1/2 divided by root 3 over 2, eventually the 2's would cancel, and I'm going to be left with 1 divided by root of 3. So that's going to be, okay, that's a quick way of looking at it. Okay, if I go 1/2 divided by root 3 over 2, these two cancel, so I'm going to be left with 1 divided by root of 3. So that's going to give us a reference angle. So if we go here, okay, let's write that down first. Tan is negative in quadrants 2 and quadrant 4. Okay, so what we're going to do is we're going to look for tangent of the reference angle. Tangent of the reference angle, x. So if that's the reference angle, I'm just going to do the 1 over root of 3, and then that it will give us pi by 6. So our reference angle is pi by 6. What's the visual for that one? So pi by 6 is right there. Okay. Remember, it's in quadrant 2 and quadrant 4. Quadrant 2 and quadrant 4. There and there. Okay. And then this is pi by 6, and then this is pi by 6. Very tiny, but that's pi by 6. So therefore, theta, or x, in quadrant 2, it's going to be pi minus pi by 6. Okay, so pi minus pi by 6, that's going to give us 5 pi by 6. 5 pi by 6. And then x in quadrant 4, it's going to be 2 pi minus pi by 6. So that's going to be 12 pi by 6 minus pi by 6 is going to be 11 pi by 6. Okay, so these two are the solutions for the domain 0 to 2 pi. 0 to 2 pi. So these are the solutions. Now, what can we do? What can we do? You'll probably notice that this part here, from here to there, we've rotated pi radians. From this to there is another pi radians, and then from here, another pi to get into that one, and another pi to get to that one. So really, we can simplify that. Okay, so we're rotating pi times multiples of pi. So the general solution we can say is 5 pi by 6 plus pi times k, where k is an element of an integer. So x amount of pi terms. Now this is interesting. This only happens for tangent. And the reason why that is because of what we talked about yesterday. Yeah, let me pull up my notes yesterday. Okay, so yesterday when we talked about tangent, okay, this is really interesting because in terms of tangent, the period is pi. So that means it repeats itself pi times, right? So that's the only time it's only works for tangent. So it ties into what we did yesterday. Okay, so we're on to the last example in example 4, so part B. Let's try this one. 7 sine theta minus 2 equals to 4 sine theta 4 sine theta minus 1. So we're gonna again manipulate this to solve for theta. 7 sine theta minus 2 equals to 4 sine theta minus 1. So bring the ones with the sign on one side and all the numbers on the other side. So what does that look like? So 7 sine theta minus 4 sine theta equals to negative 1 plus 2. Okay, we can clean that up. That's going to be 7 sine theta minus 4 sine theta. That's going to be 3 sine theta equals to 1. So sine theta is going to be 1/3. Okay, so sine theta is 1/3. Where is sine positive? Okay, so sine theta is positive in quadrants 1 and quadrant 2. Okay, so those are the two. Now let's take a look at the sine theta reference angle. So next we're going to do now let's calculate. Okay, just draw a line here so that calculate the reference angle. So what's a reference angle? So sine theta reference angle is equals to 1/3. We're going to take the positive. It's already positive there, so it's okay. So theta r is equals to the sine inverse of 1/3. Now, this is going to be not the special angle, okay, because it's 1/3. If it's 1/2, then we know it's going to be a special angle, but it's not. So theta r is equals to, okay, calculator. And I think we're still doing the radian mode. So we're going to go sine inverse of 1/3. It's going to be 0.3398 radians. So the reference angle is 0.3398 radians. So that means, okay, let's have a visual. Our visual would be, you know, it's going to be sine is 1/3 in quadrants 1 and 2. Somewhere there, somewhere there. So our reference angle is 0.3398. That's right there. And then here, 0.3398 right there. Okay, so what are the solutions from... Okay, so the solutions are theta in quadrant 1. Okay, so theta in quadrant 1 is going to be the same thing as a reference angle. So that becomes theta is equals to 0.3398. And then theta in quadrant 2 is going to be pi minus 0.3398. So pi minus 0.3398. That one I got to calculate. Is about 2.8018. We'll do it 4 decimal places here. So pi minus 0.3398. Okay, good. and these are all gradient measure. These are the for two solutions for the domain 0 to 2 pi. 0 to 2 pi. Okay, so what's the general solution? So if I figure out the coterminal for this angle here, it's going to be, to get back to that one, it's going to be, going to turn 2 pi radians. Keep 2 pi radians, or negative 2 pi radians here, right? To get to this coterminal for this one, I got to turn 2 pi radians, or multiples of pi radians, or k amount of 2 pi radians. So the general solution would be these two. It's going to be 0.3398 radians plus 2 pi k. Okay, now the reason why this is 2 pi is because the period to get back to that particular place is every 2 pi radians, where k is an element of an integer, and 2.8018 radians plus 2 pi k, where k is an element of the integer. Okay, now that's quite a bit of stuff, and that's the reason why I wanted to cut this in two lessons, 2 different days. So we did lesson 1 today, calculating first degree trig equations, and then, so you're probably thinking, okay, how do I practice this? What can I do? So for practice, you could do, try page 592. I already stated this on the blogs, but if you didn't check the blog yet, it's going to be on page 592, question number 4, 5, 6, 7, and 8. Okay, and that's it. Okay, so these are your solution. What I could do is I could do a full solutions for these ones, and then I will have to post it on Monday. Okay, so there you go. So just to kind of remind everybody that on Monday there is a test on graphing trigonometric function. It's going to be just on graphing on that particular chapter 6, part 2. And then transformation characteristics of a trig functions, trig graphs, like amplitude, period, maximum, minimum, median, all that stuff. So that's going to be on Monday, and then after that, on Tuesday, we'll continue on doing this one, chapter 7. I just want to say that we would have to speed things up a bit because there's quite a bit of lessons for chapter 7, and then we'll go at like probably 1 lesson a day, just because we're getting really pretty much done with our course, and then plus a test on this one. So yeah, just to let you know that we're gonna speed things up a bit. Okay, So have a great day, everybody. Have a great weekend. And if there is any questions that you come across, um, any question at all, just send me an email. I tried to post the full solutions to the questions that were assigned to you. But if you have questions on those ones, just let me know, and then I will go over it with you, and then hopefully I can answer them right away. Um, Perhaps on the weekend, I might be able to check my email once in a while just to see if there's anybody who has a question. But yeah, just let me know, and then I'll try to help you out. Okay, so there you go. I'll leave this with you for you to try and to do, and then I'm going to be posting this notes right away on our blog. Okay, thank you very much for watching, and have a great day and have a great weekend. Okay, I'll talk to you soon, whenever that is. Okay, bye for now.